Now let's talk about what do you mean by view and what do you mean by conflict. Okay, we'll see one by one. Now what is conflict? Conflict means there is the chance that if transaction T1 has read the data of X and after that transaction T2 is writing on X, just after that transaction T1 has read on X and after that transaction T2 is writing on X. There may be just chance like this, right? There is T1 and T2. There is a read operation on X. After that, there is a write operation on X. In between, there is no operation. This is called read-write conflict. Second possibility is if T1 is writing something on X and T2 is reading something on X just after that. It means if we have like this, we have written something on X and just after that T2 is reading. That is called write-read conflict. That is called write-read. So we have two conflict, read-write conflict and we have write-read conflict. Okay. So these are the two different conflicts. Now the schedule S convert to S dash by swapping the non-conflict instruction. Then the two schedules S and S dash are said to be conflict equivalent. What it says? It says that if there is a schedule S and S dash, by swapping the non-conflict instruction, then two schedule S1 and S are called conflict equivalent. It means that if we have a schedule, let's say T1 and T2 and T3, if I am making another schedule, let's say T1, T3 and T2, in both the schedule, all the conflict are there. Whatever conflict is here, the same conflict is here. Then these two schedule are called conflict equivalent. The schedule as is said to be conflict serializable if it is conflict equivalent to some of the serial schedule. It means if this is the non-serial schedule, and we find some serial schedule which is having the conflict, then this non-serial schedule is called conflict serializable. Okay, the same thing which I told you here. No need to be confused. Now let's talk about one example. There is two transactions T1 and T2. Here we have some read operation and write operation on it. Then we have a read operation and write operation on it. Then we have read operation on B, write operation on B. Then we have read operation on B, write operation on B. Now you have to tell me do we have any conflict here in this non-serial schedule? So we have to first identify the conflict. Now, after writing, there is a read operation. That is the conflict. This is one conflict, okay? After writing on A, there is a read on B. There is no conflict. After writing B, there is a read on B. There is another conflict. And then there is a write. So there are two write-read conflict. Two write-read conflict. Okay. Now this is a serial schedule or non-serial? This is a non-serial schedule, right? How? T1 is executing some of its operation, then T2 is executing some of its operation, then T1 is executing some of its operation, then T2 is executing. This is non-serial. Non-serial. Do we get any serial schedule which is having the conflict? Now what we can do? We have two possibility of serial. Either T1 will execute all its operation, then T2 will execute, or T2 will execute all its operation, then T1 is executing. Now, can we have any of these transaction, any of these schedule, which is equivalent to this? So for that, we have to see that all the conflict exists or not. So there is a write, read. So if I'll do, here we have read A, write on A, then read B, write on B. This is T1. This is what? T1. Okay. Now what is there in T2? Read on A, then there is a write on A, then there is a read on B, then there is a write on B. Here also the same thing exists or not. So if I'm doing T1, after writing on A, there is a read operation. Fine. And after writing on B, there is a read operation. Okay. Both the conflict exist here. So can I say that I got the serial schedule which is equivalent to this? Yes. So this is a non-serial schedule. I find the equivalent serial schedule which is having all those conflict which is here. Here we have two conflict. Here also we have these two conflict. Write and then after that read. Write and then after that read on B. Write after that there is a read. Write after that there is a read. Getting it? So T1, T2, T1 will execute first and then T2 will execute after that. It is a equivalent serial schedule of this non-serial schedule. So can I say that this non-serial schedule is serializable? Yes, it is serializable and it is conflict serializable. Now, this is another example of conflict serializable, how we can solve it. Now, could you tell me the conflict? Do we have any conflict? Okay, so this is a, serial schedule of this non-serial schedule. And we got the serial schedule, means T1 will execute first, then T2 will execute. Now let's talk about view serializable. Okay. View serializable is all about viewing, right? How we can view. So we have to view three things here. First thing that we have to view is who is reading the initial read operation. कौन initial read operation कर रहा है? Who is doing read operation initially on any data item X? Second, who is reading any data item X after write operation? After write operation, that we have to see. Second, the last, who is doing the write operation last? Who is doing read operation first? Who is doing read operation after read? And who is doing write operation at very last? These are the three view we have. And to see all these three view, we have to find out any serial schedule which is equivalent to this non-serial schedule with all the views, That is called view serializability. If you see the schedule, this is the schedule. So we have three view. Who is reading the data item A? First view. Who is reading the data item A? So T1 is reading the data item A initially, and who is reading the data item B initially? So T1 is reading data item B initially. Second view, who is reading after write? After write, who is reading? T2 is reading. After write, who is reading? T2 is reading. Now, who is doing the last write operation? Last write operation will be done on A, will be with T2 is doing the last write operation. And here last write operation again T2 is doing. So if T2 is doing last, so definitely it will come at last. If T1 doing is first, so again T1 will come at first. Can we make a schedule like this, T1 and T2? And which is equivalent and which is having all the view? So can we do that? So in this, if you'll see, Who is reading the fresh read? T1 is doing. Here also it is reading A. Here also it is reading B. Fresh read. Who is doing the last write on A? T2 is doing the last write on A. And T2 is doing last write on B. Who is reading the updated data? T2 is reading the updated data on T1. Again, T2 is reading the updated data on T2. So all the view are existing here, the same view which we have in this non-serial schedule. So can I say this non-serial schedule is view serializable? Yes. This non-serial schedule is view serializable. Why? Because I got the serial schedule. This is T1, T2 is my serial schedule. Can I say T2, T1 is my serial schedule? No, because if I'll do T2, so what will happen? What will happen? Fresh read will be done by T2, but who is reading the fresh read? T1. But when I execute T2 first, then T2 will read the fresh read, which is not view, not the equivalent view of this non-serial schedule. So I got the serial schedule, which is equivalent to this non-serial schedule, as well as all the view exist. So I can say that this non-serial schedule is view serializable.